Then once we make a histogram, we might want to look at the shape of the histogram. So there's a few different things we can look at here. One is symmetry. And these are things I've been kind of saying throughout the entire semester, we just haven't learned them yet. So a distribution can be symmetric, left skewed, or right skewed. So in this first row we have some symmetric distributions. Now this can apply to whether you're actually talking about sample data, which is going to look more like a discrete bar graph, or if you're looking at true probability distributions. These descriptions apply to them all. So symmetric is, what it sounds like. It's the same on the left and right. A left skewed distribution means that it has a long left tail, is the way I always think about it. So left skewed kind of means that you have this long tail. So you have a lot on the right and not very much on the left. So a lot on the right and then it kind of slopes down to the left. It's kind of that long tail. A right skewed distribution means you have a long right tail. So you kind of have a lot on the left and slopes down to the right. So it's that long right tail. So a few notes. If you have a left skewed distribution, sometimes called a negative skewed, then most of your bulk is going to be in the right side. So here's your left skewed here. So the right side has most of the data, but there are some extreme low values in the left. Now, since you have so many people on the right side, you would expect probably a higher average, right? You'd expect your average to kind of be over here on the right side. But or probably like here. But what happens is you have some really low values over here, and they kind of pull the average towards the low values, or towards the outliers. And so anytime that happens, your average is going to be lower than you might expect, because the average kind of gets pulled down. And so it turns out that your mean will be less than the median, or the mean will be lower than the median, because the average gets pulled down by those outliers, or those extreme low values. So let's try and think of some examples of when you'd have a left skewed distribution in life. So most people have high values, but there's a few people with low values. So I'm a teacher, so I always think about things for teaching. So the first one I thought of was scores on an easy test. Because most people will have high scores, but a few people just still didn't study and get low scores. Okay, one someone said last time was the age when people die. Because most people will be 70s plus, but some people are dying as children or teenagers, middle-aged, etc. And so more scores are up high, there's a few down low. In a positive or right skewed distribution, most of your values are in the left and just a few up on the right side. Now if you think about it, you probably expect your average to be kind of down here, but these extreme values kind of pull the average up a bit. And that means that your mean or your average will be higher than the median. And we'll actually talk about this a little bit in the next section of why the mean changes and the median doesn't. But for some examples of a right skewed distribution, we could have, okay, let's see, we want lots of people to have low values. So these could be scores on a hard test. So most people do poorly, but a few people studied a lot and do really well. My favorite example, though, is people's salaries. Because most people have kind of, like those low, normal, average, middle class salaries, but you have a few really rich people out here. Now, if you include the really rich people into your data sets, are they going to pull the average up? Yeah, by a lot. So we talked about symmetry. Then you can also talk about modes. Modes is just very graphical, like symmetry and modes are both, like you just kind of look at the graph. It's not exactly correct. You might kind of disagree with me a little bit, especially on modes. Because it's kind of just general shape. So unimodal means that you have one mode. So I used to kind of come in and sketch kind of the overall shape. So overall shape, that one looks like it has one mode, and this one kind of has one mode. Those all have one mode. Bimodal means that you have two modes, or peaks. So on this one, like, you kind of go up and then down and up and down. So you kind of have two modes. Or up, down, high, low, high. So those all have two modes. And multimodal is 2 plus modes. And so technically bimodal does count as multimodal, because multimodal is just anything that has more than one. But on this data set, I might say you have 1, 2, 3 peaks. And this one might be like 1, 2, 3 again. Sometimes people do look at these and disagree with me. Like maybe someone might say this one has 4 peaks if they include that one right there. Or they might try and argue that it only has 2 peaks. Like maybe you just go 1, 2. And you can argue that as long as you have a rational argument for me.